Welcome to the Math Record. Today I'll be finding the derivatives of logarithmic functions. So the first question is, if you don't know, what is a logarithmic function? Well, a logarithmic function, as I stated earlier in some videos, is that they're inverse functions of exponentials. So let's say we have an exponential function to the power of x. So we plug in x is equal to 1, we get back y is equal to 2, because 2 to the power of 1 is 2. Now we take the log function, log 2 of x, then if we plug in x is equal to 2, then y is equal to 1. So our x becomes our y, and our y becomes our x. So logs are just inverse functions for exponentials. Okay, so how do we find the derivatives of these logs then? Well, we just do the same thing as what we did for the other derivative, inverse derivatives. We have the original function, and then we put the inverse function inside of it. And that will give us x. Now, this is just exponential, so doing the derivative of exponential, we take the natural log of that value times the original function, which is a to the power log a of x. But since there is a function inside of a function, we use the chain rule. So the derivative of log a of x, so derivative of log a of x, and then derivative of the right side for x is just 1. So this thing already simplifies to x as stated above. So natural log of a times x times log a of x derivative is equal to 1. So that means the derivative of our natural log is equal to 1 divided by x times natural log of a. Okay, so let's try an example. So let's say we have f of x is equal to 3 log 5 of 2x. So taking the derivative of this, 3 is a scalar, so we don't have to do anything to it. Taking the derivative of our log, let's follow this formula. It's just 1 over our x. So this x is this. So that's our 2x right here, multiplied by our natural log of a. So our a right here is 5. So natural log of 5. But remember, this isn't x, this is 2x. So there's a function inside this function. So there's a function inside another function. So we have to use the chain rule. So the derivative of 2x is going to be 2. So this 2 cancels out with this 2. So all we're left with is 3 over x times natural log of 5. So this is the derivative for our function. Okay, now as we did, similar to how we were working with exponentials, where we had a to the power of x, and we compared it to e to the power of x, where e is just a specific version of a to the power of x. Well, we're going to do the same thing. So instead of log, what happened if we use natural log of x? Well, natural log of x is actually just log e of x. So working with this, we know that the derivative of natural log of x is the same thing as the derivative of log e of x, which is equal to 1x times natural log of our a. Our a is e, so natural log of e. Natural log of e is 1, so that's just x times 1. So that means we just have 1 over x. So our derivative of our natural log is just 1 over x. So as I said before, for a of x versus e of x, you don't have to remember e to the power of x derivative because that's just a specific version of the exponential. So you don't have to remember what this is. Just know that the derivative of the log of uh, the derivative of a log is equal to 1 over x times the natural value of that log base value, basically. And that basically covers everything for our derivatives of logarithmic functions. In the next video, I'll be covering implicit differentiation, which I'll bring Leibniz, I butcher his name all the time. Basically, I'm going to bring back his notation again, which is d over dx. Well, thanks for watching, and I'll see you at the next video.